Alright guys, we're going to start with problem 6.17 here. This rhodium 1 reacting with this alkene, this OTBS group and the strain cyclopropane ring. First thing we're going to do is like an oxidative addition onto this alkene. Alright. So now of course we're going to have rhodium 3. The rhodium here is bound to both of those. Alright. The OTBS is just kind of along for the ride. Now it's helpful to number the carbons. 4 and 5. And the reason this is helpful is if we take a look at the final product we're going to get to from the reaction which they give us, it's easier to see what's going on once you look at the product. So we can see we're going to expand the ring here. If you think about carbon 3 is always going to be bonded to the TBS, that's there. Alright, so that's a little helpful. I think we're probably going to add in, this electrophile, some sort of microtransfer is going to take place as well. So at this point, I think we know the rhodium is going to have to be bound to carbon 5 to help expand this ring. The problem is what's going to happen to what bond of rhodium is going to have to be broken if we're going to bond it to 5. So I think 3 and 5, this bond right here is going to be broken. We got to figure out which bond of rhodium we're going to have to break for sure. Actually, I think the bond between rhodium and carbon 2 is one that's going to have to break. So let's draw on those electrons now. So I'm going to have one electron go there, and then one electrons from carbon 2, 3 and 5 go there. This electron come around up there. This is like a quasi-migratory insertion. So we had a new pi bond between carbon 2 and 3, and rhodium is now also bonded to carbon 5. So if we go over and map on our starting material, we can see there's a carbon 2. This must be carbon 1. It means this must be 4, and this must have been 5. Let's draw the product of this. Okay, so let's draw this product. So the easiest thing to do is draw the rhodium in the middle. It's still bound to carbon 1. Now it's bound to carbon 5, which is bound to carbon 4, which is also bound to carbon 3, which now is a double bond between 2. This is 2 and 3 still has the OTBS hanging off of it. There's a double bond here. Alright, it's still rhodium 3. Now at this point, the rhodium is going to coordinate to an alkyne. And once it coordinates to this alkyne, right, you can do a migratory insertion. So for this migratory insertion, I'm going to have the electrons from the alkyne move. Electrons between rhodium and carbon 5 move to one that has the alkyne, doing a migratory insertion. Alright, following this migratory insertion, the rhodium is still bound to carbon 1, it's still rhodium 3, but now it's also bound to part of the alkyne. This is 1, 2, 3, there's a double bond there, 4, 5, and bond there. Not a very good looking ring, but we'll take it nonetheless. Now at this point, we can do our final step. We know we need to form a bond between carbon 1 and this alkene. We can do this by doing a reductive elimination, where the rhodium gets back 2 electrons. That gets us to our product. We also make rhodium 1 and regenerate the catalyst.